the first thing we should really do is find the missing side of this problem. We have the 5 and the 12, but we don't have the hypotenuse over here. So I'm just going to put an X on that. Anytime you have two sides of a right triangle and you are missing the third side, that is a job for the Pythagorean theorem. So that's when we are going to say 5 squared plus 12 squared is equal to x squared. Making sure that the number, the term that's over here by itself is always the hypotenuse. This always has to be the hypotenuse, which it is. So that's going to give us 25 plus 144 is equal to x squared. That makes 169, which equals x squared. And if you take the square root of both sides, you get x equals 13. So that tells us that the missing side is 13. And now we can answer the rest of the questions. I gave you a second copy of the notes from yesterday. I distributed again because it's pretty important. These are the definitions of sine, cosine, and tangent. So for the sine, it's going to be really important that we label which sides are opposite, adjacent, and hypotenuse. So, of course, the hypotenuse is always across from the 90-degree angle. So we know that this is the hypotenuse. So let's label that. The other two sides depend on which angle you're talking about. So for these first three problems, we're talking about angle A. So what you want to do is circle angle A and draw an arrow away from it. That tells you that the 12 is the opposite side. And that means that the 5, which is the only one left, must be the adjacent side. So now that we have everything labeled, we can do these trig functions. The sine of an angle is opposite over hypotenuse. Whoops. So that's going to be 12 over 13. The cosine is Pamela can't join. Okay, hold on. Stand by for a second. I need to invite Pamela. Okay. Mrs. Majors, just keep an eye out to see if Pamela is actually able to join or not for me, please.
Will do.
Okay, the cosine is adjacent over hypotenuse, so that's going to be 5 over 13. And then tangent is opposite over adjacent, so that's going to be 12 over 5. Now, when we do the other problems, we're switching angles now. Instead of angle A, we are now talking about angle B. So I am going to erase my labels of adjacent and opposite, and I'm going to erase the fact that I circled angle A. I can leave the hypotenuse. That's not going to change. Now we're doing angle B, so I need to circle angle B and draw that arrow going away from angle B. That arrow will always point at the opposite side. So for these problems, this is the opposite side, and that means the 12 is the adjacent side. So when I do the sine function, which is opposite over hypotenuse, that's now going to be 5 over 13. When I do the cosine, which is adjacent over hypotenuse, that's going to be 12 over 13. And when I do the tangent, which is opposite over adjacent, That's going to be 5/12. Any questions about the warm-up? Okay, now jumping over to the classwork, we're taking this the next step further. We're going to use these trig functions to find missing problems. Okay, so we need to use these trig functions to find missing values. So the first thing we have to do is label all the sides as either opposite, adjacent, or hypotenuse. The easiest one to do is the hypotenuse because that's always across from the 90 degrees. So we know that this is the hypotenuse right there. So label that. For the other two sides, it depends on what angle you're looking at. Well, they gave us the 59, so let's definitely circle that. And draw an arrow pointing away from it. We're pointing to the opposite side. So that's what tells us that this is opposite. That means the other side, which is kind of blank over here, is going to be the adjacent side. Opposite. And so now we've labeled everything: opposite, adjacent, and hypotenuse. Okay, just to shorten things up, I like to use this word that I mentioned yesterday, Sohcahtoa. It's a way of very quickly writing down all of the definitions in a short way. So I'm going to write that word down right now at the top of this classwork. I'm going to put Sohcahtoa. You got to spell it right for it to work. Okay, Sohcahtoa. All right, that's just telling us sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when you look at this picture, you have to decide which two sides are involved. So you see that we have the 28, which is the hypotenuse, and then we're looking for x, which is opposite. So the two sides that are involved are opposite and hypotenuse. Okay? The one that is not involved is adjacent. So you need to look for the trig function. Which one of these three trig functions involves opposite and hypotenuse? And so that turns out to be the sine function because there's your opposite and hypotenuse right there. The other two both involve adjacent. There's nothing on the adjacent side. So we're not going to use cosine or tangent. So we are going to use the sine function because it involves the two things that we are dealing with, opposite and hypotenuse. So let's go ahead and set up the sine function just like we did yesterday. So we will say sine. You have to put the angle, which is 59. Don't forget the angle. So sine of 59 equals. And this reminds us, sine is opposite over hypotenuse. In this case, that's going to be x over 28. So we'll have x over 28 just like that. So we have to solve this equation for x. When the variable is in the numerator, when it's in the top like this, all you have to do is multiply by the denominator. So if I were to multiply both sides by 28, watch what happens. So I'm going to multiply by 28 on the left and the right. On the right-hand side, these 28s will cancel out. That's what gets x all by itself. On the left side, we now have 28 times the sine of 59. This is something that you can simply put in your calculator. Okay, so let's put this in the calculator. So we're going to have 28. Hold on, is it glitching? Hold on one second. Let me just reset this thing. All right, so you can simply type in 28 sine 59. Just like that. You don't even need a multiplication sign in between. You can just write 28 sine 59, and that's going to give you this decimal. For this entire unit, we're going to round to 3 decimal places. So in this case, that third decimal place is a 0, but the next number is a 6. So we actually have to round that to 24.001. So that's what we have. So we have 24.001 is equal to x. And that's how you do it. That's how you can use a trig function to find a missing side. Okay? Now, watch out. We're going to have 2 types of equations so far. All right, so looking at this, let's look at both of these pictures and label everything. So the 28 is the hypotenuse on this picture. You see it's across from the 90 degrees. The x in this picture is the hypotenuse. Let's label that. Okay, in the first picture, in order to label the other 2 sides, we are going to have to circle the 59 and draw an arrow. That makes this the opposite side. That means this other side over here must be the adjacent side. Okay, let's do the same thing on this picture real quick. If we circle the 62, all right, circle the angle, draw an arrow. That makes this the opposite side. So this is opposite, which means this side over here must be adjacent. Okay, now remember your Sohcahtoa. All right, I'm just going to write Sohcahtoa. You have to decide which one of these we're going to use. Notice the 28 is the hypotenuse. The x is opposite. So that's opposite and hypotenuse. That's the sine function. Involves opposite and hypotenuse. So when you set up your equation, it would look like this, where you have the sine of 59 is equal to opposite over hypotenuse, so that's x over 28. Now compare that to the next problem. I'm going to go ahead and write Sohcahtoa again. Okay, Sohcahtoa. But when you look at this problem, we have the 17 and the x. That's opposite and hypotenuse again. Okay, opposite and hypotenuse. So again, this is going to be the sine function, all right, because it's still opposite and hypotenuse. So when we go to set it up, it's going to look like this. The sine of 62 is equal to, and we have to do opposite over hypotenuse. So that's going to be 17 over x. Now I want you to compare these 2 equations. They look very similar, but in the first equation, x, the variable, is in the numerator. In the second equation, the variable is in the denominator. So these have to be handled differently. Okay? On the previous problem, we already solved the first equation, and we saw that the way we handle it when the variable is in the numerator is we multiply. We multiplied both sides by 28. Okay, so when the variable is in the top, you multiply. All right, go ahead and write that down real big. Okay, for this situation, you multiply. That's how we solved it. Okay, now on the second problem, when the variable is in the denominator, we're going to do something different. And I'm going to call that a swap. When the variable is in the bottom, you swap. Now, here's what I mean by that. We are going to take the sine 62 part and the x, and we are going to swap these. This is legal, right? It will give us a valid equation. So if we swap these two things, notice that the 17 in the numerator, that does not move. That's going to give us the x over here by itself. And then in the denominator, we will have sine 62. Okay, now that allows us to solve the problem because we can put this in the calculator. All right, we have we have 17 over sine 62. So we can go 17 over sine 62. All right, so that gives us 19.254. Got to round up because the next number is a 6. So 19.254. Okay, so be aware of these two different types of equations. Again, when the variable is in the top, you multiply. When the variable is in the bottom, you swap these. Okay, just for the sake of your notes, I feel like I should just go ahead and write down the answer again. So we got x was 24.001. Okay. All right, this leads us to the next level. We have this, this is about as tricky as it gets. So if you can understand the problem I'm about to do now, you understand everything and you're good to go so far. We basically need to handle these triangles separately. Like we're going to treat it almost like we have two separate problems. So just to emphasize that, I think I will actually, I'm going to white out part of the problem. So for now, I'm going to ignore the triangle on the right-hand side. I'm just going to pretend like it's not there. So we can find the value of x like I just showed you. So let's go ahead and do that real quick. So in fact, you know what? In practice, what you should probably do is just draw the triangles separately. So I'm going to do that real quick right now. Okay, I'm just tracing this triangle so I can copy it. So here is the triangle on the left. I'm just tracing over it. Now I'm going to select it. Okay, so here is a copy of the triangle on the left. And you can see that we have the x right here, the 8 down here, we have the 64 right here. So I have a nice copy of that triangle. And okay, so I'm going to go ahead and copy the triangle on the right as well. Okay, so here's a copy of the triangle on the right. And if I were to label this, I've got x right here, I've got the y here, and I've got this 48 right there. All right. We're going to solve the first triangle. We're going to solve this first. Here's the right angle. Okay, right here, looking back in the picture, there's the right angle right there. That makes this the hypotenuse. And you see the 64 there. Circle that 64, draw the arrow. That tells you that this x is the opposite side, and the 8 here is the adjacent side. All right, so when you think about your Sohcahtoa, you have to decide which function you're going to use, sine, cosine, or tangent. But look at the two things that we are dealing with. We have the 8 and we have the x. All right, the hypotenuse is empty and blank. So we have the 8 and we have the x. That is opposite and adjacent. So you look and you ask yourself, which one of these three trig functions involves opposite and adjacent? Well, that's right here. See your opposite and adjacent? That's the tangent function. Tangent is opposite over adjacent. So let's go ahead and use the tangent function. So we are going to write tangent. Okay, let me squeeze it in right here. The tangent of 64 is equal to opposite over adjacent. So that's going to be x over 8. Notice the variable is in the top. And we decided a minute ago that when the variable is in the top, that is when you multiply. So that's why we are going to multiply both sides by 8. So we're going to multiply by 8. Uh-oh, why is it disappearing? Let me try that again. We're going to multiply by 8 here and here, if I can squeeze it in. That way, these 8s are going to cancel out. That gets x by itself. On the left side, we have 8 times the tangent of 64. That is something you can put in your calculator. So we can just go 8 tangent 64, just like this. Boom. Remember, 3 decimal places. So this is going to be 16.402. So we end up with 16.402 is equal to x. So that's one of the things that we were supposed to find. So we found x so far. Now we need to find y. There's not enough information in the second picture to enable us to find the y value. So we really have no choice but to use the x value that we just found. So in the previous problem, we just found that x is 16.402. So we now have to use that information. So I'm going to put the 16.402 in place of x. So now we can go ahead and do the problem. Let us label the hypotenuse. Always start with the hypotenuse across from the 90 degrees. So you know this is the hypotenuse right here. For the other two sides, you need to circle the angle that you've got. Draw an arrow away from it. That's pointing at the opposite side. So that means this is the opposite side, which means that this empty side over here must be the adjacent side. Okay, what about Sohcahtoa? All right, we have to pick which trig function we are going to use. All right, sine, cosine, or tangent. Well, consider the two values that we are dealing with. We have the 16.402 and we are looking for y. Those are the two things, the two sides that are involved. That is opposite and hypotenuse. So that is going to be the sine function. The sine function involves opposite and hypotenuse. It's the only one that does. So that tells us that we're going to use the sine function. So that's why we will write sine of 48. All right, don't forget the angle, please. Sine of 48. And that equals opposite over hypotenuse. So that's going to be 16.402 402 over y. Now, notice that the variable is in the denominator. The variable is in the denominator. And we decided that whenever the variable is in the bottom, we are going to swap these. So that's what we're about to do. Okay, so we are going to take the sine 48 part and the y part, and we are going to swap these right now. All right. Okay, if we swap these, I'm a little bit running out of space. Maybe I'll put it in over here. If we swap these, I'm going to get the y is going to end up over here on the left. Okay, the 16.402, that's not moving anywhere. But then the sine of 48 is going to end up in the denominator. So see, I just swapped these. Sometimes students will accidentally move just the 48. Just understand we're moving the whole thing, including the sine part. So we end up with this. But this is something we can put in the calculator. So that's our next move. Hold on, I need to get this over. So let's put this in the calculator. 16.402 over the sine of 48. That's 22.071. Okay, so that was about as difficult as it gets. If you can understand and follow everything I just did to take this combination problem and find x and y, then you are where you need to be if you can follow all of that right now. Okay, we're down to the last problem. Why is trigonometry, meaning sine, cosine, and tangent, not helpful on this problem right here? And the problem is we need an angle. All right, we always need an angle, right? That's one of the first things we do. We circle an angle, and then that's going to give us the opposite and the adjacent. We have no angles here at all. We have neither one of these two acute angles. So that's why trigonometry is not helpful. And let's just write that down. No angles are given. Okay, so this won't work out for us. So what do we have to do to find x instead? Well, this really goes back to the warm-up. Okay, the first thing we did, we had two sides and we were missing a third side. That is the Pythagorean theorem. A squared plus b squared equals c squared. That's not what I want. So the better way to do this instead is to do the Pythagorean theorem. And that's where we're going to say a squared plus b squared equals c squared. One more time, please remember the c squared has to be the hypotenuse, which in this case is the 38. So the 38 goes by itself. So we might have x squared plus 18 squared is equal to 38 squared, like that. Okay, they didn't actually ask us to solve this. Find the length in it, but no, they did ask us to solve it. So 18 squared is 324. So I've got x squared plus 324 1,444. subtract 324 from both sides. Okay, so that's going to give us x squared is equal to 1,120. All right, and then we just have to take the square root of both sides. Okay, so that's 33.466.